Okay, this is called the council chamber, and there's a council CERN.
Should we now be teaching our children that the Big Bang is fact, as opposed to theory?
That's always a difficult question, because clearly I was not there. We were not sitting there and watching. We were there in a kind of an abstract form because our protons and neutrons were there. So everybody, all the matter is 13.7 billion years old. I would say it's very well documented theory, and all evidence right now speaks in favor of Big Bang being a fact. I would say it like that.
Do you have an opinion on the changing in speed of light?
Well, I mean, there are theories that, you mean, now there are two questions which you could derive from that. One is the theory that the speed of light has varied over time, from the Big Bang to now. And the other possibility, which you might ask, which I don't know, is if the speed of light may be not constant as you, for example, go to very, very high energies. These are both theories which exist. For the time being, there's no evidence of any of that. It looks as if the speed of light, at least from 10 to the minus 12 seconds to now, has been constant. There's been speculations about possible effects and so on, but there's no observational evidence for it right now. And there are theories that extremely high energy gamma rays interact basically, possibly, with a kind of a space-time fluctuations in sort of quantum loop gravity theories. Same answer. It's a high speculation. There's no evidence for it. But who knows?
So, Rolf, what was it like meeting Tom Hanks? What kind of guy was he?
Oh, well, he was a very nice guy, very witty, very intelligent. He was very curious about what we are doing. And while we have been discussing the whole evening, I discovered that he was basically coming to his profession for exactly the same reason as I came to mine, because we both watched roughly at the same age the movie 2001: A Space Odyssey, and he found it absolutely intriguing. And I took the scientific part and became a scientist, and he took more the acting and the imaginary part and became a movie star.
will purely be driven by profit.
Yeah.
Okay, this is where they service the magnets. And magnetism and magnetic fields are very important for focusing the beam of protons. These are ventilation shafts, and they are to keep the air in the tunnel fresh, otherwise radon builds up. Okay, this is a model, but it represents how these magnetic pieces, the dipoles, arrive, and when they're transported into the building, they're checked to make sure that all the magnetic fields are correct, that all the soldering has been done properly, and then of course they're taken into the MHC.
For the two beams in opposite directions, and this is the beam pipe, only 5 centimeters in diameter here. The distance is about 20, a little bit less than 20 centimeters. But the accelerator, unfortunately, is a circular one, so we must put all the time the beam from one side to keep it on this circular trajectory, otherwise the beam will continue in the straightforward direction. And that's why we must have these coils, this magnetic field. It's an uniform magnetic field in this direction, and this magnetic field is creating a constant force on all the particles in the direction of the center of the magnet. Now you have only one section here, but this is the real coil. You can see here the shape of the real coil. So the beam pipe is here, and then you have exactly the same from the other side, from the downside. And one coil is about 1.20 meters, and immediately you have another one, so the beam pipes are covered everywhere with coils of this kind. What you see outside is a copper to allow the fastest possible evacuation of the heat if there is a quenching effect, if the magnetic field will be destroyed and transformed in heat.
And also this like people have taken video and edited it and it's working.
We've actually come into France, by the way.
Oh, okay, we're now in France, and we're just approaching building 193.
Switzerland.
This is where they make antimatter. Oh look, there's the door open. Antiparticle decelerator control room.
Should we go in?
Yeah, I think we should.
I'm Robert McConnell. I'm a grad student at Harvard University, and I work on the HVAC collaboration. I'm from America.
Okay, I'm so hoping that I managed to get this. It is such a shame. This is concrete and signs about the danger of radiation and lasers. Anyway, I'm going to have to leave it there, guys.
What do you think antimatter is?
Well, it's basically a particle that's identical to another one in every single way except the charge.
Why do we make it? How do we make it?
How do we make it? We bombard a target with some sort of, so often protons, but this can be anything, and a range of particles come out, and one in every, quote the number, how many? 2,000, 10,000 is a...
Because E is mc squared, so
Yeah.
energy can be converted to particles, and that's the way you make particles out of energy, and then you've got these twins, the matter particle and its antimatter.
Okay, this is my last few minutes of filming with my friends Helen and Dorrit and Richard. We're not sure because there is nobody here, but so we'll just mix some antimatter for you, and then